Hello, and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about determining polarity. What you'll learn in this screencast is how to determine a molecule's polarity. Now there are a couple of things you're going to need. You're going to need a periodic table, your molecular geometry flip chart, and I'm going to assume that you already know how to draw a Lewis dot diagram. Now, if you don't know how to draw a Lewis dot diagram, check out one of the other screencasts on drawing Lewis dot diagrams. Let's go ahead and get started. Okay, here we are, and we're being asked to figure out the polarity of the following molecules. And the first step that you want to do is go ahead and draw down the Lewis dot diagram. So I'll do that for F2. And this molecule really doesn't have a class because it's just two atoms, and so this would be linear. And for the polarity, linear molecule follows the symmetry rule, so it's going to be nonpolar if symmetrical, that is, if both the F's are the same thing, and in fact they are. So this molecule, you would say, is nonpolar. And in fact, any atom that's bonded to itself, that bond is going to be completely covalent, 100% covalent. Since it's a nonpolar bond, it can't help but be anything but nonpolar itself. Okay, for the next one, this is Mr. Chloroform. And the Lewis dot looks something like this. And the class of the compound is AB4. And that makes it a tetrahedron. And the rule for tetrahedrons is it's following the symmetry rule. That is, everything around the carbon has to be the same for it to be nonpolar. So everything would have to be all Cl's, and it isn't, or all hydrogens, and it isn't. So this is definitely asymmetrical, so this molecule, you would say, is polar. Okay, for the next example, the Lewis dot would look something like this. And this is an AB3. E, and that means the shape is trigonal. Pyramidal. And for trigonal pyramidals, the rule is pretty simple. These are always polar. They can't be made nonpolar. One of the two shapes that's nonpolar, the other being bent, of course. Okay, for the next one, this is Mr. Formaldehyde. And the Lewis dot looks something like this. And this is an AB3. And that means it's trigonal. Planar. And trigonal planars follow the symmetry rule, so everything around the carbon would have to be the same in order for it to be nonpolar, and well, we've got two hydrogens and one oxygen. So that means that it's asymmetrical, and if it's asymmetrical, it is definitely polar. Okay, for the next one, this is sulfur dioxide, and the Lewis dot looks something like this. And this is an AB2 E, and this is bent. And the rule for bent molecules is that they are always polar. So this molecule is polar. And for our last example, this is hydrogen sulfide, and the Lewis dot looks something like this. And this is an AB2E2. And this is bent again. And for bent molecules, the rule is that they are always polar. And that's how you do it. And that concludes this lesson. Okay, it's joke time once again. You know, I've often been told that I have a photographic memory that was just never developed.